All right, good morning. Can everyone hear me reasonably well? Perfect, thank you. My name is McBride. Thanks for being here for Pwn2Own Stories. In this talk, I hope to entertain you with some of my Pwn2Own experiences while encouraging you to participate. Regardless of where you are in your career, I think Pwn2Own is a great opportunity. Quick poll of hands. I know it's early, so we're going to try to make this interactive. Who has heard of Pwn2Own before? Okay, a few people. Okay, well, at this point in my career, I have quite a few gray hairs as I've been doing vulnerability research and reverse engineering for more than 17 years. As mentioned, I'm currently the Android team lead at L3 Harris Trenchant, and my research is focused on the Android kernel and Chrome Sandbox. Previously, I spent about 13 years at San Diego National Labs and the Oak Ridge National Lab doing lots of fun things that I can't talk about. In my spare time, I would like to participate in Pwn2Own. And I hope in this talk I will convince you to also participate and show you that it can be fun and profitable. So this talk will highlight 6 short stories from Pwn2Own Miami in 2020 and 2022. There'll be 3 successes and 3 failures, covering a variety of targets, technologies, and approaches. There'll be some .NET, some Java, some cryptography, and some weird Windows stuff. All of the stories are related to ICS, Industrial Control System, and SCADA products. If you're not familiar with those types of products, they run power plants, hydroelectric dams, water treatment plants, factories. They're used in lots of important places. So a little bit about Pwn2Own. It is a hacking contest that's run by the Zero Day Initiative. And from my perspective, researchers get paid for bugs, which is nice, and all the vulnerabilities get reported to the vendors. So ZDI will run multiple contests annually, targeting common software used by many people and software that is important to secure. This software includes really hard things like Chrome, Microsoft Windows, Apple products, include the iPhone. There's even contests targeting Tesla, where you can win a Tesla if you hack it. But then there's other products that are less splashy, things like your home entertainment speakers, like Sonos products. There's also home automation products, electric vehicle chargers, and again, things that run power plants. So there's a wide spectrum of targets in these contests. So the last contest that ZDI ran paid over $1.1 billion in values. So it can also be quite lucrative. The basic rules of Pwn2Own: targets are announced about 3 months before the contest, and now this is real vulnerability research. There's no special access given, no product source. So this is as if you were a real attacker. So you have to acquire the product, grab firmware if it's a product that has firmware. You have to identify the attack surface. Everything is real. All bugs in the exploit chain must be 0 days on the day of the contest. If the vendor or CPI already knows about the bug, it doesn't count. Participants will get 3 attempts in a 15-minute span to demonstrate code execution. It's not enough to just come up with a bug. You have to demonstrate a working exploit against code execution. So to get a full contest win, bugs must not be known by ZDI or the vendor. Okay, so why should you try Pwn2Own? One, it's fun. You can get paid quite a bit. It's a really good resume builder. A lot of vulnerability research firms look at Pwn2Own as a check box to say you know what you're doing. But I think this is the most important one. It's an opportunity to learn new things. You've got a wide spectrum of technologies and lots of Pwn2Own or going after a Tesla, and I hope it encourages you to try yourself. Okay. For the first story, we go to Pwn2Own Miami in 2020, where we target the Rockwell Automation Factory Talk View, SE, HMI, and EWS. Now, don't worry if you don't understand what that particular piece of software is or does. I don't understand what it is or does either. It's just a piece of software. And it turns out the system ends up configured as 3 VMs, lots of different processes, lots of network ports open. So where do we start? And I think this is a common problem for beginners, is there's a big piece of software. What do I do? It's so big, it's intimidating, and so I'm going to walk you through exactly what I did. Now, this particular approach does not lean on any experience. It is the silliest thing you could do to start, and it works. So how about just browsing with the web browser to each open port? Maybe we can identify an HTTP server. Now, hopefully you all know better ways to do this, because this is not a good way to do it. But if you did do this, you will find that you get a really interesting exception on one of those open ports. What makes it interesting? Well, there's keywords like deserialized, and binary server formatter, and remoting. Now, there's probably people in this room that know what this means. I was not one of them when I saw this exception. But I did know enough to Google. And so one Google search later, we find an article by James Forshaw describing vulnerabilities in the .NET remoting protocol. The .NET remoting protocol allows for deserialization of untrusted objects by design. Now, again, you don't really need to know a whole lot to be successful here. You just need to know that deserialization of untrusted objects is bad. Does anyone know that already? Good. Okay, you can win at Pwn2Own. Now, Forshaw adds that there are ways to mitigate this. One is to not use remoting. So if you're using .NET remoting in your systems, don't do it. He further adds if the service is running with the type filter level set to full, then even with these fixes, the service can still be normal. Now, I started reverse engineering the server and quickly saw that type filter level was indeed set to full. Okay, so this is really good news for me. 20 minutes later, I've got to work with exploit. I used a tool called YSOSerial to generate a serialized object that would take advantage of the binary formatter protocol in .NET remoting. Didn't have to know a whole lot there, just had to type a command line. A little bit of Python to send my serialized object to the vulnerable endpoint. And the end result is a 100% reliable exploit that worked on both the HMI and the EWS software. Now, unfortunately, this particular bug ended up colliding with a bug reported in 2019. So at Pwn2Own, this is a partial win. It was released as a 0-day in February of 2020, as the vendor had not fixed it after 120 days. I haven't looked recently. It might be fixed even today. So don't use their software. Okay. Now, this was a very shallow bug that was always likely to be found by researchers. It's, however, a very accessible bug for beginners. Again, if you knew very little, if all you knew was to browse to open ports and could do Google searches, you can win with this bug. It's a great opportunity to learn a little bit more about .NET and deserialization issues. And really the hardest part of this entire process was reading the blog post on .NET remoting. Okay. The second story is also from Pwn2Own Miami in 2020. This time we are targeting the Iconics Genesis 64 control server. Again, it's not really too important what it is, other than it's a giant .NET application with some native code. Instead of using legacy .NET remoting, for client-server communications, it uses the Windows Communication Foundation. I don't understand why it's foundation, not framework, but it is. Chris Anastasio presented a really nice talk at B-Side San Francisco in 2019, talking about how to abuse WCF endpoints. Again, if you can use Google and you learn WCF vulnerabilities, you can find this great talk and you can win at Pwn2Own as well. So it turns out this WCF endpoint in Iconics Genesis 64 allow for unauthenticated access. The WCF endpoint would allow for talking to a wide variety of what they call point managers on the server. And the main ICO FWX server proxies these requests to other services depending on the point name as provided in the request. Now, I had a winning bug, but it was patched the week before the contest, and so I scrambled to find another one in time. This was very stressful. But the good news is, after reverse engineering, I learned the GDX point manager handles several methods related to the database of the product. So there were functions like get database schemas, get table columns, get SQL servers procedure, test query. Yep, it takes an SQL query from the remote client and runs it without authentication. Now, I am not an SQL expert by any means, but this seems bad. Okay, so what went wrong here? Well, in the last few hours before the contest registration closed, I wrote a custom WCF client to trigger the test query function. It leveraged Iconics supplied PowerShell commandlets to get all the necessary configuration information that I needed to call test query. I hunted for RCE options besides using XP command shell, since that's configuration dependent, and everything worked. 5 minutes before the contest, everything worked as I expected. And then on stage, it didn't work. This camera's going, it was actually live on Twitter, and my exploit wasn't working. I had no idea what was going on. It turns out that the PowerShell commandlets stopped working. My demo license had expired, and the commandlets wouldn't run without a valid license. This really sucked. I couldn't get back in the 15-minute time window to demo the exploit. So I don't know quite what the lesson there is, other than don't write lazy exploits. I could have written a better exploit that would have grabbed all that configuration information without depending on the vendor supplied PowerShell commandlets, but that would have taken time. Okay, so this one really hurt. Thankfully, the Iconics Genesis 64 control server was back in 2022, but there was a rule change. So in 2022, an attempt in this category must be launched against the target's exposed network services from the contestant's laptop within the contest network, or by opening a file within the target on the contest laptop. The files that are eligible to be opened must be file types that are handled by default by the target application. So this is nice. So I started looking at all the file types that were handled by Iconics Genesis 64 by default. And for each file type, I did a quick visual scan of the available files in the install directory for interesting data and keywords. This was a very simple way to start. Nothing complex here. So I would open up the file, try to read for clues to the purpose of the file. Is it compressed? Does it look encrypted? It'd be really nice if there were serialized objects in the file, because then I could probably send my own serialized objects and win again. But as I was browsing, I found one file that had code in it. There's an XML file, and it had keywords like script code and JScript net nice. So I found that the TDFX file, which really isn't important, the GraphWorks64 template file, could be opened without authentication. And if I just added 2 lines of code and a script code tag, again, the particular code isn't important other than that it executes calc. And I really don't know what it's doing, but I can do Google. You do that, throw it in the file, open the file, and you pop calc. Easy. Okay? Not hard. This is a very weak bug. And I had a lot of angst over whether I should submit this bug or not, because it was trivial to find, and likely others would find it as well if it wasn't killed prior to the contest. But at this time, I had 2 kids, and I didn't have lots of time, so maybe I would just give one. Despite being a 5th entry to target iconic Genesis 64, it was a full winner. It didn't collide with any of the previous attempts. There are more details in the blog post, but there's really not a whole lot more than code in file, Google, win. Now, I've later learned that at least 2 other researchers had the same bug and opted for deeper bugs. But again, the point is that even at Pwn2Own, there are easy bugs that are accessible to a wide variety of researchers. Okay. Our 4th story starts at Pwn2Own Miami in 2020, where we're targeting the inductive automation ignition SCADA control server. It's just one big Java web app. The main web app listens on port 8088, and there's a gateway network port on 8060. This is probably the most difficult example in my 6 stories. So really this is how do you start? So what code is reachable? And I'm not really a Java guy, so I was starting at the very beginning, web.xml. So I started by looking in the file, Googling what are these things called servlets. They're just classes that handle HTTP requests for different URL patterns. And I started by examining the control and data flow of each one. So here's an example servlet from the web.xml file. You can see it handles the /system star URL pattern. And there's probably a whole bunch of people in the room saying, yeah, this is 101 Java and 101 web apps. Kind of important. The servlet class, the map servlet, handles all requests on the URL. Okay, so if you start examining the code for the map servlet, you'll find that it registers a number of subservlets that handle subpaths on /system. So I would start by auditing each one, in turn looking for suspect code. And the gateway servlet is first, and it also sounds kind of interesting. Post to system gateway are handled by the gateway do post method, and it expects some XML describing a message. Going through each message type, we find that message type 199 allows for a type of RPC function. The RPC functions are subclasses of the abstract gateway function, and most of them require authentication by being part of a valid session. So the default implementation defines this is session required method, and the default is to return true, so it has to be authenticated. Now there's a number of interestingly named functions that require a valid session, things like module invoke, call sproc, run query. I love things like this. Security funcs, script invoke is my favorite because you can exec supply Python code, but you have to be authenticated. So that's not so great. However, not all of these gateway functions require authentication. This particular gateway function called getDiff does not require any authentication. So is session required returns false. And the function takes in a string called effective project base64. I have no idea what this means, but it passes it to this method called base64 .decode to object fragile. Now I really like seeing things like that, fragile. Thanks developers for giving me a hint. And if you follow that, you'll find that eventually they create an object input stream and do a read object. This is a deserialization of the data provided in the string. So again, this is a classic Java deserialization vulnerability. I used YSOSerial again to build a payload because they used an old version of Apache Commons. And then I posted the payload, base64, in proper XML format to System Gateway, and it's a winner. Now, this was a partial win at Pwn2Own because another research team had this bug, and they got to go first. They have a really nice write-up on this if you want more details. But this was not a particularly hard bug to find. Again, if all you can do about Java was that deserialization of untrusted data is bad, this was doable. Beginning to end, this bug took me about 8 hours to find. Okay, next, inductive automation ignition was back at Pwn2Own Miami in 2022. And this time, I decided to learn how session authentication works. Because remember, if authenticated, we can win with the script invoke gateway function, and I can just exec Python code. Okay, so I started digging into the authentication, and what we find is when we create an authenticated session, it generates a session ID. The session ID gets put into a hash map of sessions. When I remove a session, all it is a removal from the session's hash map. And if I want to know if a particular ID is authenticated, it just does a lookup in the session hash map. So how are these session IDs generated? Lots of gobbledygook on here. Doesn't really matter. The main thing is that it pulls bytes from a random number generator. There's a little bit of math on there, but it's all deterministic math, so it doesn't really matter. So we have to ask, how is this random number generator initialized? We find that server startup, the init random function gets called. There's a seed based on the current time in milliseconds of the system. And then the random number generator is seeded with the seed based on the current time in milliseconds. Now, I am not a cryptographer, but what I do know is that seeding a random number generator with the system time is not usually a good idea. So my idea was I can brute force the session ID of a logged in user, then get RCE with the authenticated script invoke function. Okay. And then I failed miserably. My brain started telling me that's no good, as it requires a user to be logged in, and that won't be allowed under the rules. A few months later, there's an advisory that comes out, followed by a blog post saying that the ignition server is vulnerable to authentication bypass due to a poorly seeded random number generator. And it turns out a simple email to the Pwn2Own organizers would have confirmed this as a valid scenario under the contest rules. So if in doubt, send an email. I felt it was too bad. For our final story, we fast forward about a year later when I noticed an interesting post on Twitter. So CVE 2023, inductive automation ignition, Java serialization codec, deserialization RCE, and then there's a ZDI advisory saying about the same thing, that this Java serialization codec, deserialization of untrusted data, use remote code execution. So I started flipping through my notes from the prior year, and I found this page in my notes. I've got highlighted at the top this WebSocket control servlet service where data comes in, and I got the control and data flow path all the way down to Java serialization codec.encode with the infamous star saying this is really good. I even talk about deserializing the server message header. So I've got the beginning of this to the very end, and so the question is, what went wrong? I honestly have idea. And this is the really frustrating part about this failure. So I took no more notes beyond this one page that highlights attacker control data coming in all the way to a winning bug at the end. I have no POC whatsoever in my attempt to prove or disprove that this was a good bug. Got nothing. So I guess the moral of the story is write better notes. You should always document your work. Always POC if you have something, because you just never know. Could be a winning bug. So why should you try Pwn2Own? I hope at this point you believe that Pwn2Own is a good learning opportunity and something you should consider doing. I think it is a lot of fun. There's a wide variety of targets, a wide range of skills and approaches can be successful. I think even students can be successful at Pwn2Own. Not all these targets are hard. If you've done 1 to 2 CTFs, you are ready to try some of these targets. You can get paid. That's always fun. You can also build your reputation and resume. I think that one of the most important aspects of Pwn2Own, though, is that opportunity for feedback from others. If you go honestly after one of these targets, whether you succeed or fail, you can learn from the successes of others and can improve your processes and the way you do your work. Okay, thank you. I hope you enjoyed this talk. Thanks to ZDI for hosting Pwn2Own. Thanks for Elstree Harris Trenchant and Oak Ridge National Lab for supporting me, participating. Lastly, thanks to B-Sides ABQ for hosting this wonderful event. And I'll take questions.
I know nothing about Pwn2Own, so is it individuals or can you do it in groups or
Great question.
certifications?
Nothing is required for entry. There's no barrier, no degrees, no certifications needed, nothing. You can participate in teams. There's a lot of individual participants, but plenty of people will team up with 2 or 3. I think that there's been teams as large as 5 or 6 in some cases. All right, thank you.
Thank you so much.